Hello, everyone. Thanks for joining me today at this webinar about caching Made Bootiful. This kind of, if you will try to find this beautiful word in any vocabulary, you probably couldn't find it. However, if you try to Google it, probably you will find it in some presentation from Josh Long. I can say he's the author of this kind of word new word in new in our software development right now. And today we're going to talk about beautiful application that based on the Spring Boot and how you can enable caching, how you can enable distributed caching in your Spring Boot applications. So how many of you guys? I guess we have a pool here. Ben, do we?
Yes, we do. This is the first time I've used the poll tool, so let me pull that up. Give me one moment.
That's great. Something is first time, right?
All right. All right. You want me to go ahead and
yeah. So I just interesting, like how many of you guys today using the Spring Boot in your real life, like in production. Also, I'm interested how many of you using Hazelcast with Spring or Spring Boot applications. Also, have you ever heard about JCache and maybe some of you actually using JCache as a part of your application? So basically, this kind of questions that help me understand like our audience better. So what I'm going to talk today is you'll understand that it's going to be like a three-part of the live coding and demo session. We're going to talk about the overall architecture of the Spring Boot application, what kind of problems that we might end up in, how we can solve these problems with caching, how you can make the caching distributed by just literally adding a couple lines of code in your Spring Boot application, and how you can enable the standard APIs like a JCache API in your Bootiful application, I would say. Without further ado, I think I will start with some demo.
Let me go ahead and close out the poll real quick, Victor, so that you've got that information.
Yeah.
If anybody wants to fill out the poll, I see a few of you guys still haven't done that. Now is your last chance. So go ahead and fill that out, and then I'm going to close it so that everybody can kind of see breakdown of the answers here.
So if you can see, I'm just sharing IntelliJ IDEA. Okay, nice. Wow. It's actually, it's surprising that still in 2015, it's already over a year that Spring Boot around. Not many people still using the Spring Boot in production. However, there are few people who actually use this. I'm really pleased that people using Hazelcast with Spring. I think this is the right thing to do, and we're actually investing a lot of engineering power to integrate with Spring and work with Spring engineers. Another thing that really sad to me that since 2014, when the JCache was ratified, and we still have not many people heard or use JCache at all. I hope after this presentation, you guys will change your mind a little bit and start using the JCache more. All right. So what's the what would be idea for my demo? I'm gonna start with IntelliJ IDEA as my IDEA of choice, and I will start typing the code right now. I'm going to start with new project, and I'm going to use the Spring initializer. Also, if you're using different IDE and not using IntelliJ IDEA, or IntelliJ IDEA doesn't, your version of IntelliJ IDEA doesn't have this plugin, you can go to the Start Spring.io the website and do pretty much the same. This is the way how you usually start with new Spring Boot application. And my IntelliJ IDEA provides me with nice wizard that allows me to generate the skeleton of the application. So let's today we're going to call about caching, Bootiful, and webinar, right? And as you can see, Spring Boot developers actually provide the some of, I would say, the starter packages for caching. So I'm going to check this, and in this case, all required dependencies that my Spring Boot application would use will be attached to my project. So I'm going to do one more thing. I want to use Gradle here. I'm a more like Gradle guy. I want to use Java 8, of course. I will enable auto import. Okay, so what it gives us a basic Spring Boot application. Basic Spring Boot application. This is regular Java class that annotated with the Spring Boot application annotation. So if I will run this, so what you will see right now is this is actually Spring Boot application ready to use. Doesn't do anything particular that will be interested in. However, it still works. Everything is there. All dependencies are here, right? So one thing about explaining a little bit of Spring Boot application. So there is a annotation that we have on top of the class of our application, and actually this annotation is meta annotation. This is annotation that composed from different other annotations. Couple of things that we need to know here. So first of all, this is this Spring Boot application annotation contains of Spring configuration annotation. If you are not familiar with the concepts, there are three different ways how you configure your Spring Beans. You can use XML, you can use Java configuration, or you can use Groovy configuration. In this demo, I will be solely on Java configuration, and moreover, I will gonna stay in just one file because the Spring Boot annotation allows me to type my configuration, my Java configuration, right here in my caching application. Oh, somehow I just close it. My IntelliJ IDEA. I apologize for this. Okay, so we get back. All right. So another thing that we can notice here is that Spring Boot application also contains of component scan annotations that allows me to put the component inside this class and allow me to use a dependency injection using auto-wired annotation or inject if you're using JavaX injection. JavaX injection classes. So let me switch back, and as the premise of this application, I'm going to start with simple service called my city service. So this is a simple interface that will allow me in my application just getting city. And because I said I can create the configuration inline. So what I will do, I will create the bin that will create the instance of my service. So in this case, I have city service get city. Let's make it public. And let's make it bin. So in this case, I need to provide the way how I can instantiate my my bin, and I'll just do it in line here, new city service, and return. I'm in New York City, so in this case, NYC. Sorry, a little bit of groovy habits. All right. So what happens here? Inside our configuration, I provide the bin that we will use in our Spring Boot application. So to sort of provide some of the logic of our class and start typing something inside our application, Spring Boot provides the class called command line runner, where we can actually provide this logic of our application flow. So so in this case, I need to implement interface command line runner, and inside here I can do whatever I want. So how about first of all check if we can do something with the service. In this case, I can use outwired annotation to inject this service here, and let's do service get city. Simple enough, right? So I start my application, I execute my logic. This bin was injected from the configuration. This is the way how we defined logic, and we're good to go. So to add a little bit more of experiments here, I also want to the benchmark, how this method performs, and we know the best benchmark is system.nanotime. Okay, service time. So in this case, I'm collecting the start time, collecting end time, and I want to know how long it would take to execute this method from perspective of time. So it's almost everything happens almost immediately, right? So to simulate real world problems with latency, usually our service is depend on multiple other layers of our application. In this particular case, it doesn't do anything. It just simply returns a string. However, in real world applications, we need to call database, or we need to call some external service. And in the microservices world, it might be called to multiple services. So potentially inside this method getCity, there would be multiple calls, and the latency and the time of execution of this method, it would be tremendously higher than I have it right now in terms of like 0 milliseconds. So what I can do is the best way how we can simulate the latency, even though I not recommend to do it in production. We're adding 3-second slip. And when I run this, we will see the method call takes me 3 seconds. If I will run this multiple times, let's do like this 3 times, right? Of course. And each and every time when I will run, it will take me 3 seconds. So imagine that in your situation, you have multiple calls, not 3 calls, but each and every calls you have a 3 seconds delay. And being as a very smart and very savvy developer, you already optimized everything. You optimized the network, you optimized the database, you built indexes, you optimized your HTTP calls, and everything seems to be normal, right? So there is no way how you can optimize more. However, there are some certain things that you simply cannot, optimize. For example, there's some calculation involved, and there's a time you can bring even more expensive machines, but it still takes some time. So for some sort of data, sort of results of data, it's always good. You can, if the data is impotent, so the result is always depend on input parameters, you can actually enable caching. And with Spring Boot and Spring, it's actually very easy. So what you need to do here is use magic annotation, enable caching, and inside here you need to specify which method will be cacheable. And you can say cache name is city. So what happens here with this magic annotation? Will it help? Will it help in our scenario? As you can see, it magically helped because first time it took us 3 seconds to calculate, and rest of the time it was just simply result was taken from the cache because the input parameter, there's no input parameters here. Now, this is very nice. This is very nice and very good. However, not always you're running just one instance of your application, because right now in very scalable world, we try to create, if we need to just support more load, we just need to spin another instance of JVM. But let's see how this caching help in this kind of situation. So if I will start 2 instances, as you can see on my right side, I'm running 2 instances of applications. We still have one problem. And this problem is initial startup, right? And because by default, without anything else, Spring is actually using the concurrent hash map as the cache. So the concurrent hash map data structure allows you to store some local values. However, in case of distributed situation and your services needs to use the same data, the concurrent hash map needs to be synchronized somehow, right? So in this case, we need to find something better to be our cached the storage. So there's a couple of things that you can do. So, but simplest thing is to add Hazelcast into the mix. So what I will do here in my Gradle, in my build.gradle, I just need to specify Hazelcast dependency. So Hazelcast all, this is what you need in your build script. In my application, all I need to do is define one more bin. It's a bin. With Hazelcast instance get instance that returns Hazelcast new Hazelcast instance. Oops. Now, what I will do, I will just simply restart my application. And I will start another application. So first time it took us 3 seconds, 1 millisecond. And the second application simply reused the cached value from previously calculated result. So in this case, I would just simply, I will run it one more. Once again, 3000 milliseconds, 1 millisecond for the second call, 8 milliseconds for the first call, 7 milliseconds for the second call. So from my perspective, this is like great success, right? So in this case, even though initial startup took us 3 seconds to run the calculation and store it inside Hazelcast, all calls that happen after took us no time. So in this case, we with a couple simple lines, and as you understand, the Spring Boot is a very nice tool in terms of like a magic. And many things that happens right now is actually include a lot of things that make it past possible. So what happens here with auto configuration, actually Spring Boot auto configuration for Hazelcast will look for bin with type of Hazelcast instance. So in this case, Spring Boot will instantiate the cache manager that will take the Hazelcast as an instance. So in this case, all these calls that will be the proxy, generated proxy, will be delegating to the cache manager will be translated into the Hazelcast code. And what only thing that you need to do is adding them into your class path. It may happen by Spring Boot developers and Hazelcast developers working together and bringing the Spring integration on that level. Okay. Another very interesting thing that might occur to you is that, okay, so what's going to happen? What's going to happen if the all instances of this application will go away, right? So we running the application and now we simply shut down. We need to start over, right? So we need to start over, and the first application needs to recalculate this data to populate cache. So the other applications needs to read this application. However, in the world of like microservices, we can sort of separate responsibilities from our application into another application. So we're moving the storage of the cache outside of our application. Our application essentially wants to be the consumer, a consumer of this data. So it's very simple to do and very simply to change. So let me show you how. So in this case, what I will do, let's call it cluster, right? So I'll create a class cluster, and inside the public static void main, I will create Hazelcast, new Hazelcast instance. I even can create 2 instances. So in this case, my application will contain 2 Hazelcast members. I think that would be nice. And so let me run this, and I will run the cluster guy first. So in this case, this application will start Hazelcast as cluster that we're going to use in our Spring Boot application. So one simple change, and we're moving from embedded Hazelcast topology, which application embeds Hazelcast inside it, into the traditional client cluster topology. Now, if I will start this application, so first call will take me some time. because the first time we calculating this. That's interesting. It took even more than I asked. I asked for 3 seconds. For some reason, I waited 5 seconds. Okay. Let me run another application. 1 second for the first time. Not bad. Okay, that looks really good. So what happens if I will kill all my instances of my Spring Boot application? So I'll kill this one. I kill this guy, and I kill this guy. Now, if I will restart, so in this case, because we separated storage from actual consumer, the storage persisted somewhere else. So in this case, this is our service. And our application just used consumer. So as you can see, from perspective, another very interesting point here that as you can see, both Hazelcast client, new Hazelcast client method, and new Hazelcast instance, they both return Hazelcast instance, the instance of this interface that allows us to, or allows developers to not depend on the particular topology or depend on particular Hazelcast member or Hazelcast client, but rather use Hazelcast instance as unified API for accessing Hazelcast data. But can we do better? Like, can we do better without even some proprietary APIs? So what we have here right now for cacheable, we're using annotation from Spring Framework. For our cache manager, we're using Hazelcast, and etc. Can we do better? And luckily, Spring provides our implementation of JCache. So since Spring 4, Spring provides support of JCache, and including JCache cache manager, that's that we can find in class that holds inside the Spring context support jar. So one thing that is missing here is JCache jars. So let's add JCache jars into the mix. So what we need to do, add one more compile time dependency, JavaX cache API, and we can actually, as a matter of fact, we can actually remove this guy from here at all. So our configuration will not contain this. And we a little bit, I need to modify this guy. I will shut down, and I will shut down cluster as well. So I need to modify this guy, and okay. So what happens here? I just need to provide CT. I need to provide the caching, the JCache provider, and I'm starting JCache server using Hazelcast instance. So, so from perspective of this application, I will start this guy. And once again, I want to get rid of the cacheable and use standard annotations. So in this case, there is a similar annotation in JCache called cache result. With cache result, I need to provide the cache name, and the cache name is city. So as you can see, I use the JavaX cacheable annotation, cache result annotation, and no mentioning of the Hazelcast at all here, right? And it still works. It still works, works as a charm, works beautifully. So, but you can ask, okay, so it works fine, but how we can do, how we achieve the same result? Like, let me run one more application to confirm that everything works. As you can see, it works fine, works great, and everything is awesome. So Spring Boot actually allows to select JCache provider. And using the application.properties of the Spring Boot, we can actually specify this. So what we'll do, we can type this property called Spring Cache provider. And because of magic, that third component of this demo, it brings in this, it's the IntelliJ IDEA. Because of the magic of IntelliJ IDEA in integration with the Spring Boot, the IDE shows me that couple providers available here. So by default, the way how it's done, client provider used by default. However, you can enforce it to use server provider. So in this case, if you use this guy and you will start your application, let me stop this guy in this guy, and if I will run Spring Boot application, so in this case, instance of my application will join the cluster as the instance of Hazelcast member. But if you change this caching provider here, we will get back to the situation where we were at the very beginning with a typical client configuration. So what I will do here is I'll do client caching provider. So in this case, we're changing topology. What? That's very nice. Let me try to restart. Sometimes because I'm using multicast in the Mac OS X, multicast doesn't pick up really nicely. Okay, so it looks like the cluster didn't get back to stable state. So what I will do is I just simply restart the cluster. It didn't pick up my multicast config really quickly. Okay, so still we get back to right status, 3 seconds, and if I'll start another application, still works as charm. So as you can see, so from as you can see from a couple lines of code, without actually coding any cache logic, without coding any explicit checks for cache or specifying distributed topology, client server topology, and etc., you can achieve multiple things. And it's pretty easy. As you can see, most of my code is actually print line statements. So let's recap it real quick with my with my slides. So as you remember, we started this Spring application with just a simple bean definition that contains some slow code. And first thing that we did is we enabled caching for this application using enable caching annotation with Spring. Also, we can specify what method needs to be cached. So in this case, we annotated getCity and provided name of the cache that will store the result of the method getCity. We're just adding one more bean into the mix, bean that contains Hazelcast instance. We enabled distributed caching within our application. And in my example, I can use I used actually like I commented out lines, right? I commented out the Hazelcast member instantiation and change it with the client instantiation. However, in your application, you can use a combination of profile bin, profile annotation. I'm sorry, and you can change the application topology without changing the code using the profile annotation and being that annotated with profile. You can set topology using just environment variable, for example. And the third thing is brace the standards. Use JCache in your applications. And implementations of JCache are quite mature since 2014. There are many, and it actually doesn't, need to be in this particular situation. There is no even mentioning of Hazelcast configuration. So this is pretty much it that I wanted to talk to you about today. How to enable caching. I hope you learned this. How to enable distributed caching with Hazelcast, and how to use the standard distributed caching with Hazelcast and JCache. So I will get questions, and I guess Ben will help me with this one. And I'm ready for your questions.
Do you hear me?
Yes.
Oh, hello, Victor. My name is Michael. So thank you. It was very interesting. And my question is, what about consistency? Does transactional annotation works for there? And is it possible to keep consistency if many cache regions are changed transactionally? No.
So the question is actually not about consistency, but how we can use with transactional annotation. So this is
probably a little bit. Okay. Thank you. Mm-hmm.
This is a little bit sort of like a different concept. So if I'm going to talk about the Hazelcast, so Hazelcast actually can participate with GTA transactions. So Spring provide the integration with GTA transaction, and Hazelcast can participate this. So in terms of using these annotations and how it works with transactional approach. So currently it's not using any transactional approach when you do just a cache result or at cacheable, right? In terms of not more like consistency, but more like linearization of operations, right? So this is because the Spring uses Hazelcast synchronous API. So in this case, it provides the same linearization guarantees as the Hazelcast synchronous API. So it depends on the configuration. You can configure synchronous writes and synchronous backup. So in this case, data will be it's more like consistent guarantees that we have. Configuration-wise, you can change the asynchronous backups that will introduce less consistent result. But it's all about requirement of application. If you need to have this, it can be configured.
Could you point some links, or because this is important because it's not about transactional. It's about if we have many entities which are related, and we need to consistently change them and reflect it in cache or any, let's say, for example, cache expiration. If many region should expire and be consistent in terms of related data, it might be not only. So, by the way, transactional annotation supports not only GTA transaction, also it might be GMS transaction, for example. So it's could you provide some links or some how to support transactions and consistency if I use Hazelcast client and many providers change Hazelcast data, and I need to have consistent Hazelcast on client side. I need to have consistent data across, for example, many maps inside Hazelcast. Thank you.
Yeah, we have this in our documentation, and I'll ask Ben to follow these links with Hazelcast documentation that contains exactly what you're asking, like how to provide transactional access to multiple Hazelcast data structure in one operation.
Thank you.
I have a question here. Is if cluster is down, what happens with client application that use Hazelcast client? Will it be broken? So if cluster will be down, first of all, client will try to retry. There is a configurable number of retries that can be attempted, and after that, application needs to know how to recover. So the same way as you're recovering from failure on database, if your database is down, your application needs to know how to recover. Same here is with this application. So in this case, will it be applications broken? It depends how it's written. Some application can tolerate failures and reconnect after. How to evict entries from the cache? Actually, it's a great question. So how you can the way how you evict in caches from the cache is if you can use the JCache annotation cache evict that will annotate method that will explicitly will be invoked and the entry will be evicted, or you can configure but in this case it's just a configuration of the Hazelcast or JCache. You can provide the configuration on so first of all, for example, when I have this configuration for the cache, when I'm creating the cache, this class actually allows me to specify eviction configuration for the cache. So in this case, there's a method set eviction policy expire policy factory that will contain configuration for eviction. For more information, I will also forward you links to JCache documentation, how you can configure it explicitly. So in this case, it will be handled by JCache implementation itself, like automatically. I like that kind of questions. What's the advantages of Hazelcast then comparison to other in-memory solutions such as GridGain? So first of all, they're both like great products, open source. GridGain is the enterprise version of Apache Ignite. Hazelcast is open source thing, and everything that I demonstrated works with the Hazelcast open source. Spring guys provide the support for the JCache. So there's pretty much, if the GridGain guys provide their integration, it's pretty much same webinar can be can be run on the GridGain premises. But the question about like I actually can provide the link for a comparison guide. We have extensive comparison guide between Hazelcast and other in-memory solutions, including GridGain. We will follow up this link. Thanks for this question, by the way. So question is how we can define the Hazelcast configuration as we do for map, high density, and other features that provide from the Hazelcast. So very good question. So if we're using first on the second step, remember I used the Hazelcast here when I defined my my bin with Hazelcast instance. This guy, right? You can do it pretty much the same the way how you do with Hazelcast. Only thing that you need to do is to have a file called Hazelcast XML. With Hazelcast XML, where is it? Hazelcast server. Cancel. And you can configure your say map city. For this map, you can say in memory format native. So in this case, it will use high density memory. Plus, you need to configure native memory enabled true, and pretty much it. So you still can use your previous knowledge on Hazelcast configuration, and in this case, when this instance will be created, this instance will pick up Hazelcast XML, and the configuration will be configured here. Same thing for JCache. You can have this configuration for the cache here, and the same way you can configure in memory format as a native for JCache as well. How we can configure a write-through cache. So in Hazelcast maps, there's concept of map loader, map store. In JCache, there's the concept of cache loader and cache writer. And this is kind of this is the way how you can configure write-through cache using the API. Again, I will forward the links for this question to our documentation. It's actually well described in documentation. Okay, so if I don't have any other questions, I want to say thank you for your time, for joining me today for this webinar. I hope this information will be useful to you. And we'll send a recording after this event very shortly. And don't hesitate to reach out to us. I'm tweeting at Twitter. You can ask any questions there. And thank you. Follow us, and you will learn more about that kind of stuff in our next webinars. Thank you, guys.